Hey guys, in this video I want to show you how to create a really simple neural network using Keras in Python in just a few minutes. Let's get started. Firstly, of course, we need to install some packages. You can see it here in this cell. I recommend to do it like in the first cell because it's important in the future to organize your machine learning projects. I always recommend this because it can eliminate some problems and errors which can arise because you use unimported package. So please do that in every project you have. As we can see, I already imported some data, and this data is about breast cancer. So here we can see like a lot of features, and we have a class. 0 means no breast cancer and 1 means breast cancer is presented. So here we can see that there were some missing values, and we already captured them by using nav values here in reading CSV. Then I also dropped them because neural network will not work with any nav values. As you can see, I already separated the data into X and Y. There is one important thing. It's really important to separate your data into two pieces. First piece will be features that I used to classify some record, and the second piece is the class, which we want to predict. So usually we use X to identify the piece with features and Y to identify the piece with classes. It's something like a convention between data scientists to do so. Then we can see that we use train test split function from scikit-learn library to split our dataset into two parts, train and test. For that function we use X and Y, which we identified earlier, and we use test size of 20%. I think that's enough. And also we use random state. It is a parameter that is used to make our work reproducible, so people can also try to use the same program and obtain the same results every time because they will have the same data sets and data splits. Now it's the time to write our own code, so let's get going. As we already worked with the data, and if you guys don't know how to work with the data, how to prepare it for machine learning, we will learn it in later videos, so don't be afraid. Now we can go further to the neural network itself. So firstly, of course, we need to identify the model, which we will use as in all machine learning algorithms. So for example, we want to call it model. And now we need to identify the class of that model, and it is sequential. What it basically means is that our network will have a linear stack of layers, which means that all the layers in the network will be connected with each other, and they will go into the linear manner. So we go from left to right every time, like there is no swaps or going backwards or anything like that in this neural network. It's actually the simplest type from what we have, but it's enough for this simple classification problem. Then we need to go and add some layers. That's the very interesting part. We can really customize it a lot, and I encourage you to try something yourself after the lesson. So for example, we will add the first layer, which will be a dense layer. Dense means fully connected. That means that every perceptron on the previous layer is fully connected to the other perceptrons on the next layer. And that's also the most simple layer that can be used, so we will use that also. Firstly, we need to identify the number of perceptrons in our first layer, and it can be a little bit less than the number of inputs. As we can see in the table, we had 10 columns, so 10 inputs, but we also have class column. So we need to subtract 1 from 10, and it will be 9. So we have 9 features, 9-dimensional input. So we need to use number a little bit smaller than that. So we will just use 8. I always use even numbers, but I think you can use any numbers here. So now we need to identify also the input dimensions because it's the input layer, the first one. So we write input dim is equal to 9 because we already discussed that there is 9 features for every record that goes to the network. Then we also need to identify the activation function. Activation function is the function that produces a great input for the next layers. So instead of just bringing the weight sum of what perceptrons produced, it gives the next layer a great number to work with. So usually we use ReLU. It's a really easy function. If the produced weight is bigger than 0, it returns this weight. If it is lower than 0, it returns 0. So it's a very easy function and you can always use that. Now we need also to add some more layers. We'll use actually 3 here. So we add the second layer. Oops. And it will be also the dense layer. And here we need to use less number of perceptrons. So let's bring in 4. Also we need to define activation function, which will be ReLU also. Cool, we have 2 layers. Now we need to create third one, and it will be the output layer. So let's do that. Just writing model add, and then also defining dense layer. And we have only one output because it's a binary problem. So we have here binary classification. So we need just to produce one output. So that's why we write 1. And here we need to define activation function of sigmoid. It is the activation function for every binary problem. It produces the probability of being in the first class. So we have 0 class and the first class. And yeah, it just produced the probability from 0 to 1. So, okay, we created the model. Now we want just to look at it. So let's do that. To look at the model, we can use model summary. And let's do it. Yeah, we can see our model. It's like really nice. It has 3 layers and 121 parameters. So that's really cool. We can actually go with that. Let's add one more cell. And in this cell, we will try to compile our model. Before training the neural network, we need to compile it. It means we need to provide the loss function, optimization algorithm, and also metrics, which we will use to assess the accuracy of our model. So here, we need to write model.compile. And here we need to write some important things. First one is optimizer. Optimizer is that component of neural network which is used to correct the weights in every iteration. So it's something like the thing that optimizes the weights in the neural network. So we need to use it. And there is some very popular ones such as gradient descent or Adam or RMS prop, but we will use here just Adam. You can use Adam in every neural networks because it's like one of the best optimizers that exists. The next parameter here is the loss function. Loss function is used to calculate the loss in every step. Okay, for example, it's really easy to obtain loss function for regression problem. It just means squared error. But here it's kind of more difficult. But in every binary classification problem, we just use binary cross entropy. Binary cross entropy is the loss function for binary classification problems. And it's really easy to just remember it in these types of problems. It's used like everywhere for binary classification. Then we also need to define the metrics. We write metrics, and here in the list structure, we write accuracy, because we want accuracy to be measured. Of course, we can use some other metrics here, such as recall or precision, and that would be okay, but I want to use just accuracy here, for simplicity. Okay, so we can just run it. Cool, that works. Okay, so we can go to the last step of the process. We will fit our model. To do so, we just use model fit. And here we need to write some parameters, which will be xtrain, because we're training in x and y train. Then we need to write the validation data, which we will use. Validation data is the test data. We write it in tuple form. So here we can use x test, y test. Then we also need to write some more things. First one is epochs. And I think we will use something like 40 here. Epochs is the number of iterations through whole dataset. It's not the number of iterations of the neural network itself, because this number can be much bigger than number of epochs. But it's just the number of how many times the neural network see all dataset. So here we define 40, which means that our neural network will see the dataset 40 times. Okay, also we need to define batch size. Batch size is the metric, which means how many inputs, how many records goes to the neural network at once. So here we need to use, I use something like a mnemonic rule for that. I just need to have the biggest possible number, but under 10% of all data. Here we have 700 rows, so we can use something like 64. And also I usually use powers of 2. We can actually just run it. And we can see that it's really fast. And we can see that on the 40th epoch, we can see that the validation accuracy is 92%, which is nice. But we can see that here in some previous epochs, it was 93. So that's the problem of overfitting. We can see that our neural networks try to overfit to the training data. So we can use some more smart algorithms such as early stepping to prevent our neural network from doing that. But I think it's okay for now. 92% is also really nice. So one more thing that I want to do is to assess the results. How accurate is the model? For this, we will use classification report from scikit-learn. Firstly, we need to produce predictions. To do so, we use the same syntax as we used for scikit-learn. So we use model.predict. And here we just write xtest. And we need also to save it in ypred, which means predictions. Okay, that's cool. Let's look at ypred. It seems nice. It's an array. Okay, now we can create a classification report. To do so, we can just use classification report. And here we need to write ytest, because firstly we need to use true values, and then ypred. And okay, there is an issue. That issue is really interesting, because we need to use predict classes here, because we see the probabilities here, but we need to predict classes. So if we do so, we can see the actual classes here. So let's go and try to do classification report again. Yeah, that works, but it's so ugly. Let's use print for that. Okay, that's nice. So we can see that our accuracy is 93%. Yeah, we can see that here we have precision, recall, and F1 score. And we can see that the results are not so bad. It's okay. But that's a little bit bad that we are worse in predicting first class, because it means that there is a cancer. And it's not the best thing for medical problems, but that's okay. We can stay with that. Cool! We just created the neural networks in just 8 minutes, I think. So you can find the code to it on GitHub, which will be under the video, and I wish you enjoyed the lesson. Stay tuned, subscribe, give me some likes, and just wait for another video. Goodbye, guys!